Euler's summation formula. Euler's summation formula says that if f has a continuous derivative f dash on the interval closed interval yx was 0 less than y less than x, then summation y less than n less than or equal to x f of n equal to integral y to x f of t dt plus integral y to x t minus greatest integer less than or equal to t f dash of t dt plus f of x greatest integer less than or equal to x minus f of y into greatest integer y minus y. So for this proof, what we are taking is, let m is equal to greatest integer less than or equal to y and k is equal to greatest integer less than or equal to x. Okay, then for integers n and n minus 1 in closed interval yx, so we have to prove that this f dash has a continuous derivative only on closed interval yx. So we are taking integers n and n minus 1 in closed interval yx. Then integral n minus 1 to n greatest integer less than or equal to t f dash of t dt. I can write it as integral n minus 1 to n minus 1 f dash of t dt, because I will write the reason here, because t is between n minus 1 and n minus 1 less than t less than n. So greatest integer less than or equal to t must be n minus 1. Greatest integer less than t must be n minus 1. That is why I taken here n minus 1, which is equal to n minus 1 integral n minus 1 to n f dash of t dt. So here integral derivative. So we get n minus 1 into what we get. I am taking the values. So f of t we will get, then f of n minus f of n minus 1, which is equal to n into f of n minus f of n minus n minus 1 into f of n minus 1. I can write like this. So which is same as writing n f of n, this n minus 1 f of n minus 1 I am taking here, minus n minus 1 into f of n minus 1 minus f of n. So called equation number 1. So integral n minus 1 to n greatest integer less than or equal to t f dash of t dt equal to n f of n minus 1 f of n minus 1 minus f of n. But we have to calculate for m to k. Here we have only taken two integers in this closed interval yx. Now we are calculating for m to k. So we can sum from what, m to m plus 1, m plus 1 to m, then up to k minus 1 to k. These integrals are here. I can say integral. So integral m to m plus 1, integral m to m plus 1 greatest integer less than or equal to t f dash of t dt equal to applying in equation 1. In place of n we have here m plus 1, in place of n minus 1 we have m here. So which is equal to m plus 1 f of m plus 1 minus m f of m minus f of m plus 1. Similarly we will get integral m plus 1 to m plus 2 etc. So I am taking integral etc. Integral k minus 1 to k greatest integer less than or equal to t f dash of t dt, which is equal to k f of k minus k minus 1 into f of k minus 1 minus f of k minus f of k. So thus integral m to k. What is m? M is actually greatest integer less than or equal to y. K is actually greatest integer less than or equal to x. We have taken like this in the beginning of proof. So integral m is integral m to k greatest integer t less than or equal to t f dash of t dt will be equal to, here we have kf of k, okay, kf of k then this k minus 1 f of k minus 1, it will be cancelled. When we look at this, these terms will be cancelled, but we have minus f of m will be there in our sum. Then what else? These f of m plus 1s, yes, f of m plus 1, f of m plus 2, up to f of k will be there. So I can write k f of k minus m f of m minus, I am summing this. We have f of m plus minus f of m plus 1 minus f of m plus 2 etc. minus f of k. So I am taking it as summation. N is from m plus 1 to k f of n. So actually, what is the sum? We have m plus 1. We have m is equal to greatest integer less than or equal to y. So what we can say about this summation, I can let me write this. So this is equal to, this is same as writing, that is integral y to x greatest integer less than or equal to t f dash of t dt will be equal to, actually what is k? Greatest integer less than or equal to x, f of x minus greatest integer y f of y. M is greatest integer y, isn't it? Y. Then we have this summation. This summation I can write it as minus summation y less than n less than or equal to x f of n. It is very clear. X is greatest integer less than or equal to x. M is greatest integer less than or equal to y. But here we are taking from m plus 1. So y less than n less than or equal to x. What we needed is this value, isn't it? Euler summation formula is for this value, isn't it? So we need this value. So I can write it as summation y less than n less than or equal to x f of n will be equal to greatest integer x f of x minus greatest integer less than or equal to y f of y minus integral y to x greatest integer t f dash of t dt. I can write like this. Call it equation number 2. Call it equation number. So by integration by parts, now we are taking integral y to x f of t dt. When we take integration by parts, that is 1 into f of t dt, what we will get? It's equal to x f of x minus y f of y minus integral y to x t f dash of t dt. This we get. X minus x into f of x minus y into f of y minus integral y to x t f dash of t dt. T minus greatest. So what we have is integral y to x f of t dt equal to x f of x minus y f of y minus integral y to x t f dash of t dt. Now what we are doing is, when we minus integral y to x f of t dt from this value, what we get? It is equal to 0, isn't it? So I can write x f of x minus y f of y minus integral y to x t minus f dash of t dt will minus integral y to x f of t dt equal to 0. I can write. Isn't it? Call it equation number 3. So here actually I wanted to write 0 here in the LHS. So when we are equation 2 is here and equation 3 is here, I am letting 2 minus 3, which is equal to summation. This will get in the LHS, and in the RHS what we will get, we can see. So equation 2 minus equation 3 implies summation y less than n less than or equal to x f of n minus 0 equal to some greatest integer less than or equal to x minus x into f of x plus y minus greatest integer y into f of y plus integral y to x t minus greatest integer t into f dash of t dt plus integral y to x f of t dt. So what we get? Therefore, summation y less than n less than or equal to x, f of n will be equal to integral y to x, I am rearranging this, f of t dt plus integral y to x t minus greatest integer less than or equal to t into f dash of t dt plus greatest integer x minus x into f of x minus greatest integer less than or equal to y minus y into f of y. This is the Euler's summation formula.